All right, thank you, Tom. I will also be at PASS Summit. As we discussed, I can't promise I will make breakfast every morning. You can usually find me hanging out by the SQL Cat Clinic, which honestly is probably worth the conference fee for attending PASS alone. It is fantastic. You get to meet directly with the SQL Cat team, and you can just rock up, bring up your problems, and just present them to them, and have some of the most experienced people in the world with SQL Server look at your problems. I mean, I think that's worth the conference price alone. Okay, today we're going to talk about running SQL Server in AWS. Hopefully everybody can see my screen. I'll do a little quick intro into, who am I? So, as Tom mentioned, my name is Brian Carrig. I manage a team of DBAs, awesome DBAs, at a company that's called Channel Advisor, based in the North Carolina Raleigh area. I've been working with SQL Server for about 7 years now, and I am a Microsoft Certified Master. I was one of those that was lucky enough to kind of squeak in at the end of the program, which is now sadly defunct. In case you can't tell from my accent, I'm a native of Dublin, Ireland, but I currently live in Carrig, North Carolina, which gives my kids a very interesting accent. Previous life, I worked as an academic, and if you have some kind of insomnia problem, please feel free to look up my PhD online about distributed networking. Okay, so agenda. I'll cover basically the background of why I became interested in running SQL Server in AWS. Talk about some of the expectations that we have for the session. Obviously cover your options for running SQL Server in AWS, how you might get there. Pretty quick, pretty brief overview on HANDR. A good colleague of mine, Tracy Baggiano, talks a lot, and she will actually be presenting at PASS Summit talking about monitoring availability groups, but I'll give a quick overview of HANDR in AWS, talk about monitoring. I promise the briefest slide you can imagine for licensing, and just some of the learnings and takeaways that we've had that we've kind of discovered when we've been running SQL Server in AWS. All right, so the background to this project is basically my company acquired an EU-based company, and this company had a legal requirement that they had signed contracts with several large manufacturer-type companies like Siemens, Philips, and so forth. And in this legal contract, it said that the data cannot leave the EU region. But shortly after we acquired the company, we were basically given, hey, you've got a week to move out of the current colo because the contract is ending. So rather than scour Europe looking for a new colo, we already have a contract with AWS. We have a relationship there. Our sysadmins have a good amount of in-house knowledge with AWS. They're comfortable with AWS. We said, well, okay, it makes sense. Why not run these SQL servers in AWS? All right, so some expectations for the session. I don't have any kind of agenda around whether you should or shouldn't use the public cloud, in the same way that I don't have any agenda as to whether servers should be physical or virtual. I always advocate you should do whatever makes sense. I work quite closely with the SQL Cat team at Microsoft on a lot of cases. So when we mention that we're running a SQL Server in AWS, they go, hey, have you heard about this thing we have that's called Azure? Well, yes. This is not AWS is better than Azure. We don't have any familiarity, or basically we don't have workload that runs in Azure. So we don't have systems administrators that work with Azure. We don't have any automation built around Azure. And that's the only reason that we picked AWS in this case. It is no statement that says that AWS is better than Azure or anything like that. Also, I don't have any demos in this. I do just have an hour, and it's always been a struggle to keep it just to that time frame. But this is not a how-to guide for how you spin up an EC2 instance or an RDS instance in AWS. There's lots of information online. I'm planning to post some stuff around how to do this in PowerShell online, but basically we won't be doing a step through in this particular presentation. What I am hoping is that we could help you make some informed decisions. If you have your boss coming to you and saying, hey, should I be running this in AWS? Will we move everything to AWS? I'm hoping that you can make informed AWS decisions based on this talk. Understand if your workload is suitable for AWS, and also if you, regardless of your opinions, if you are running workload in AWS, I hope to give you some tips to how to make SQL perform in AWS. And I'll briefly touch, assuming we don't run out of time, I'll briefly touch on some of the caveats that we have come across for running SQL Server in AWS. And I will say, Tom will, I believe, take the questions if they come in over text. Please feel free to interrupt me at any point. I won't be thrown. Nobody needs to feel the need to keep their questions right till the end of the session or anything like that. Just as you have questions, please feel free to toss them out there, and I will be happy to answer them if I can. Okay, so your main options when it comes to running SQL Server in AWS. And I talk a lot about virtualization as well. I've been an early proponent of virtualization, and I've worked with VMware a lot, Hyper-V less so, but VMware a lot. And running what they call EC2, Elastic Compute, is very similar to running a VM in a private cloud infrastructure on premise. But the key thing that you need to take away, and if you take away nothing else from this presentation except this, I would say just remember that this is not your infrastructure. That's the key takeaway point. And so for that reason, right sizing in AWS, or I'm assuming it corresponds in Azure, it's even more important than with private cloud VMs. So it's really, really important to make sure that you pick the right instance size for your workload. RDS is what Amazon offers as its managed database, relational database service. And they do this across a couple of different platforms, so you can pick Postgres, their own particular fork of MySQL, which is Aurora, MySQL itself, MariaDB, which is Google's fork of MySQL, Oracle, and SQL Server. And these are somewhat analogous to having a VM where you are not the sysadmin, which as a DBA is kind of upsetting, right? It's like, why are you locking me out of my own server? Backups, patching, high availability, these are things that are managed for you with the tick of a button. But you still need to do everything else. So when people think that, like, hey, the whole platform as a service means that we don't need DBAs anymore. Well, one, there's DBAs managing this at the back end. And the other thing is that, you still need to take care of security. Somebody still needs to maintain the indexes. In some ways, this frees you up, especially if you're in a situation where you are the lone DBA for a company. This will free you up to concentrate on things that might be more important for the business, like performance tuning. So there are two options, and the idea of choosing a managed service does not mean that you become irrelevant. It just gives you an opportunity to focus on something else, which may in real life be more important to the business than backups. Personally, I would say there's nothing more important than backups for DBA. Okay.
Hey Brian,
I'm a DBA.
we have a question here that has come in, and you may answer
Sure.
you may answer it a little bit later on, but I'll go ahead and pop it in here. Uh,
Yep.
have you experienced I/O issues with running SQL Server on AWS, and if so, any solutions?
Oh, hell yes. And there are two solutions, both of which I'll cover.
Okay, and then the second one is, so with EC2, do we need to manage our own backups and patching in HA then, since RDS does that for us?
Yes. So if you're running on an EC2 instance, you can consider it, as I say, analogous to your systems administration team has said, here's your VM, do whatever you want. So you install SQL Server, or I mean, I'll cover this in a little bit, but there's the concept of AMIs, Amazon Machine Images, equivalent to templates in VMware. I'm not sure what if it's a same term in Hyper-V, but it's a template. You can build your own private ones. Amazon have some public ones, but yeah, it's that concept. You are responsible for all of the installs, configuration, setting up maintenance, everything. It's just not running in your data center. It's running in Amazon's data center.
Okay, that's all the questions for now.
Okay, I'll keep going. So RDS, and it's kind of funny. I gave this talk at a couple of different SQL Saturdays, and I'm surprised by the amount of people that are actually running RDS, because the limitations are quite severe. So let's just go through the limitations quickly here. So limited to 30 user databases. Your access to system databases is very limited. Your maximum storage size is 4 terabytes, and you cannot extend this. You're limited to, and again, I'll cover discussion about instance types in a little bit as well, particularly as they pertain to EC2 instances. But basically, you've got, if you want to bring your own license, you've got 2 instance types, and if you want the license included option, which is the really expensive, I'll pay for my SQL license by the hour, you're limited basically to 1 instance type. You're locked out of most of the server level roles and permissions, except for process admin, which allows you to kill sessions, which of course is always fun, but if you're used to having sysadmin level privileges, it might be frustrating at times not to have that level of permissions. If you want to do time zone changes, are very restricted. You can't restore from one time zone to another time zone. There's basically no, and you can't change your time zone. Personally, I've never kind of encountered a scenario where I've wanted to run my SQL server at a different time zone than the server itself runs, but I at least want to highlight it as a restriction. The level of restore granularity. So if you have cases, and this was a deal breaker for us when we were working with RDS for a lot of circumstances, is that you cannot do point in time restore. No stop at mark or stop at time. You get to restore to a 5-minute period within the last whatever your restore retention policy, database backup retention policy is. So, and that might be fine for a lot of cases, but we would definitely have cases where we would not be comfortable restoring except to an exact time, which you cannot do. I'm assuming the 5-minute interval is based on the frequency of log backups, but yeah, that was a pretty big deal breaker for us. Other features that you were locked out of, brace yourselves: stretch DB, link servers, buffer pool extensions, polybase, change data capture, replication, availability groups, server level triggers, endpoints, file stream, SQL audit, policy-based management, instant file initialization, which is crazy because it's Amazon storage that you're actually working on, bulk operations, database mail, which is also a big deal for a lot of places, no maintenance plans. And anything outside the engine, basically anything I don't care about, those things are also not available. So analysis services, integration services, reporting services, master data services, those are all not available to you in RDS. Okay. So now to talk about what makes a good workload candidate for AWS. So
Hey,
for
Brian,
us in particular, sure.
Quick question, is RDS very similar to Azure SQL DB then, in as far as the maintenance goes up on AWS?
I actually think it's almost, they've approached it two different ways. So Azure SQL DB, and my experience with this is pretty limited to just, playing around with it. But Azure SQL DB is a multi-tenanted solution where they kind of manage, the noisy neighbor scenarios, and they handle everything on that side. So you can think of RDS as we've spun up a VM for you, and we've locked you out of anything we think you might do that will be dangerous, and we'll take care of like basic maintenance.
Okay.
So that's where the difference lies.
All right, that's all.
Okay. So good workload candidates for AWS. In our case, we have a team of system administrators who really like working with AWS. They've built a lot of automation around AWS. They're very comfortable with AWS. So that really helps, So that is definitely something to consider when you're considering a particular public cloud to choose. And it's obviously it's not just between AWS and Azure. There's also Google Compute Cloud, Rackspace. There's still quite a few options out there. You will, and this goes back to my point that it's not your infrastructure, so you don't get to size the instances typically. If you're big enough, there's a possibility you will get custom size instances, but typically you got to go with what's available. And so you would want to make sure ahead of time that the size of the instances makes sense for your workload. I have definitely found that the memory sizes are somewhat smaller than I would typically like. So the core to memory ratio is a little bit smaller than I would typically like. And this goes back to making the most use of your licensing because SQL Server, you license per core, but as long as you're on Enterprise Edition, there are no limitations on memory beyond what the OS will limitations. So it makes sense to maximize. Everybody knows memory makes the database go faster. So maximize the amount of memory usage that you can. Things have gotten better quite recently. Amazon released this ability to expand what they call EBS, and again, I'll talk about this in a minute. It's their SAN equivalent, Elastic Block Storage. It's their equivalent of a SAN. But if your capacity growth is kind of very predictable, like on a year-to-year type basis, well, then that can help when it comes to migrating workloads to AWS. If you're really unsure, it can make things difficult. But as I say, less of a problem now that they have made it possible to expand EBS volumes online. And I have done this in production, and I can say that it went very seamlessly. If you've got a new product or a trial product, your typical developer comes to you that says they're about to release the next Facebook in the next sprint cycle. Sure, whatever. AWS is a good kind of place to put that. If it starts to explode as much as the developer hopes, well, great, and then hopefully your company's making money from this product, and then you could look at possibly migrating it back on-prem. But it's a good experimentation place where you don't commit yourself to 3 years of CapEx to buy hardware that may or may not be used. I gave the example of the case where we had purchased the company and the company had legal restrictions on where the data resides. It's a very easy way. You have one relationship to manage with AWS, but you can constrain your data to particular geographic regions, basically anywhere in the globe. I would also say what I probably terribly refer to as half-managed instances. So these are the independent software instances, so stuff that maybe backs up the VMware product or just various bits and pieces that are not my main concern, but obviously I still have to manage these SQL instances. RDS is not a bad option for sticking them there. At least I know everything will be backed up. I'm not always going to be the team that's going to be paged if these go down. I don't necessarily want to be paged out of hours for these. So RDS can make sense for some of these instances, even though, as I mentioned with the previous restriction, just be careful. These they get backed up, but there's pretty much no other maintenance besides backups and patch management. For very bursty, kind of 8x5 type workloads, previous role, as I mentioned, I worked in academia. We would beat the hell out of servers 8 to 5, then we all went home. You could have shut them down after that. This is a good candidate for AWS. Any applications that you have that might use SQL Express, this gets you around the limitations of not being able to use SQL Agent. You're basically looking at SAN snapshots, so you can recover SQL Express. Pretty much any SQL Express instances that I manage now are done through RDS. Okay.
Hey, Brian.
Sure.
Tom Stabe from AWS is on, and I chatted to you. He said that they've increased the RDS SQL Server storage limit to 4 terabytes, and in August we expanded it now up to 16 terabytes.
Yes, this is this is definitely the problem with I never suffered from this problem until I started giving talks about any cloud-based products.
It's constantly moving.
It's constantly moving. So I apologize if there's and I think this is up to date as of I want to say at least 3 to 4 weeks ago. So I apologize if anything is out of date, but yeah, literally this stuff is changing all the time, every single day. And there are even some things I'm aware of that are on the horizon that are NDA that I can't talk about, but that also solve some of the problems that I mentioned here. But yes, so up to 16 terabytes now with RDS?
Yep, that's what he says. I expanded it in August. So, yeah, I remember my Azure talk. I was constantly basically said, check me out because it's always changing. So,
yeah, and please feel free to follow up with me offline. I will be happy. I have contacts in the AWS, and I'll be happy to kind of figure out anything that anybody might have questions about. My understanding is still, so for EBS volumes on EC2 instances, you can expand on the fly, but my understanding is because of the way they do striping for RDS, you still have to kind of like pick a number and just stick with it.
All right, and no more questions.
If there's anybody else from AWS who's on here who wants to kind of contradict that, please feel free to jump in. Okay. Some things that I would consider potentially poor workload candidates for AWS. If your capacity route is kind of highly variable, which is something that we have a lot, and I mean, as I say, you can expand on the fly for EC2 instances, so it's less of a problem, but it's also not necessarily quite as easy as you would typically expect, or as I would typically expect, because I just toss a ticket into our systems administration team and say, hey, make this bigger. It might not be quite that easy for you. If you have a HA or DR plan that's based around a particular technology, like, hey, use VMware Site Recovery Manager or use something else, if it's going to interfere with that, well, then you really need to take a step back and say, what am I gaining here? If the instance sizes that are available, and again, I will mention that if you're a particularly large customer, I mean, there's some accommodation around this. But for most customers, if instance sizes do not make sense for you, and I will say, SQL Server is a very memory-heavy resource, and a lot of the instance sizes, even what the instance sizes that they refer to as memory optimized, can be a little light on memory. So that's something to be aware of. If your finance team is very cost sensitive, because one thing that comes up occasionally is that, like, hey, we could just move to the cloud and we'll save all this magic money, because it goes from the pool that says CapEx to the pool that says OpEx, and that works fine up until you actually start spending it. And then they say, oh, this is a lot of money. It is not a way to save money. There's a lot of benefits from moving to the cloud. Saving money is not one of them, unless you have a particular workload that you can make that makes sense in the cloud. For example, if you can shut things down regularly, that makes sense. If you have a very well-defined workload, you can really like know, this is my workload for the year. Well, you can reserve instances in advance, and you can potentially get some gains there. I will say there's no reason at all. So we personally, we fall under, we don't have any HIPAA compliance, but we do have Sarbanes-Oxley. We previously had PCI DSS, we don't anymore. But if you have any of these kind of compliance regulations, it is, and GDPR is coming up next year, something everybody needs to be aware of if they want to do business in the European Union. There's no reason at all that you can't be fully compliant running in AWS. In fact, it actually solves some problems for you. You get an initial kind of like, we've already taken care of these kind of problems. What I have seen, and it's not a problem with my current company, but what I have seen in the past is a mistrust of the public cloud from the security team. They find it difficult to justify, or it causes them problems. Like you might end up with additional, basically additional paperwork to fill out because of the fact, just purely because you're in the public cloud. There's no reason you can't be compliant, but if it's going to cause you all of this extra aggravation, and I mean, I joined a job as a DPA, and I find that now possibly 50% of my time is spent working on audit and compliance work, which I never really anticipated. So if this is going to cause you a lot of additional conflict, and nobody likes to get into conflict with their InfoSec team, so if this is going to cause you compliance conflict just through policy-based reasons, well, then it is something to be aware of and to consider. This is no reflection on the public cloud. It is, you can make it absolutely as secure as your own colo data center. This is more a case of almost, this is a humans thing, right? So this is, they may not understand. So you have to take that into account and consider it. We use Enterprise Edition hosts. We're a fully virtualized shop on-prem, and we use Enterprise Edition, and we use host-based licensing. You definitely can do this in the cloud, but it's not super easy. So again, something to be aware of if that's your current licensing model. Okay, moving ahead to EC2 instance types. EC2 instance types, these are basically VMs, right? And it's all really simple because Amazon does not over-provision their hardware. So if you want to run on the i3 class, and we'll talk about the classes of hardware, but you can think of class as corresponding to a particular hardware configuration. It's really simple. You can run 16 i3, 16x or 16 i3 larges, or one i3 16x large. So super simple. And as I said, no over provisioning. What you do need to potentially take into consideration is that to make sure that the instance types that you pick matches your workload. I would be careful about picking like, oh, well, this one matches like what I need right now, but if I need to, increase my workload, then I have to move to a different instance type. That could potentially, not always, it depends on the processor architecture, but that could potentially involve moving to like having to migrate your data. So you want to try and avoid that. So try and choose the instance type that matches your workload and gives you a little bit of headroom if you need to change. If you're on the same instance type, making it bigger, as long as there's room to escalate, is basically a shutdown or restart as a larger size. So size according to your needs and to your budget. So I'll cover a couple of different instance types. I'm not going to want to go super in depth on this. One thing I will point out that the T2 class, which is really cheap, and this is the only class that Amazon over provisions on. And what they do is, while you run under a limit, that you accumulate credits that you can then use when you burst over a limit. That limit's about 60% of CPU utilization. So for dev test type machines, if you're running less than 60% most of the time, these can work out as a very cheap kind of option for you for dev and test. I would not recommend these for production. I see a lot of SQL Server instances running as general purpose, which is kind of fine, but I would say that the amount of memory is possibly lighter than you would typically expect for a SQL Server. C4, Amazon goes out of the way to kind of not quite mention that these are really good for Bitcoin mining, but they're really good for Bitcoin mining. Moving on to the instance types that make a lot of sense for SQL Server. So we have our X1 class, and Amazon is working on giving us more variations of degrees of this. And these are the ones that make a lot of sense in the CPU to kind of memory ratio. The problem at the moment is that you really only get the big options, and that's fine. If you're running a tier 1 workload, I mean, I think a lot of usage for this is SAP HANA, which has quite high memory requirements, but also can make sense for very high-end SQL Server workloads. One thing to be aware of, particularly now that we have SQL on Linux being GA, is that it will cost you $50,000 a year less to run this X1 instance class as a Linux server instead of a Windows server if you're paying the base licensing. You're not bringing your own Windows licensing. You could find yourself, having to justify, why do I need to pay $50,000 a year just for Windows? That could be something to consider. For most workloads, I would suggest that the OR class, which is what Amazon calls their memory optimized class, I would say that this is probably your best fit for most workloads. One trend that you will notice, and Tom, I presume we make these slides available, or I guess we're recording. One thing that I would mention is that the newest generations, the thing that Amazon has done is they've kind of removed local storage and instead massively improved the throughput to the EBS volume, essentially the SAN storage. And I've noticed a trend in all my time working with, I'm working with AWS probably 2-3 years now. One of the kind of trends that I've noticed is that I will complain about a problem. They will say that it's absolutely not a problem and nobody else has mentioned it, but then they fix it in like 2 months after we've had to make a different decision. But one of the things that we always said was that, like, in some cases you would have really high-end workloads, and I'll talk a little bit as well later about the idea between generally provisioned and provisioned IOPS. one of the things that we noticed is that we were having to pay quite a lot of money for provision IOPS, whereas really our bottleneck was throughput, but that was our only way to guarantee throughput. I will say that now, as long as you're on the newest kind of instance types, like so if you're an R4 rather than R3, most of your throughput problems are solved. So they've gone an order of magnitude up in throughput. So we also used to have to do a lot of crazy stuff, or well, depending on your mindset, maybe it's not so crazy, but we had to, in a lot of cases, we had to RAID 0 stripe across multiple volumes in Windows just in order to increase our throughput level, which can be kind of concerning as a database administrator. But okay, so I'll talk about EBS, or Elastic Block Store. So this is the SAN of the AWS world, and they guarantee 5 nines of availability. It automatically replicates to a different availability zone, and I'll cover availability zones in a little bit, but basically an availability zone, the way Amazon sets up data centers is they split them into multiple availability zones, typically 3, and these are serviced with separate internet, separate powers, basically they're like separate data centers that are kind of co-joined. And the idea then is that you can spread your resources, and this works really, really well for availability groups, is you can essentially have your 2 or more replica nodes in different data centers, potentially with automatic failover between data centers, which is kind of amazing. And when you explain it to management, it looks like magic. It makes you look like a hero. So, and it's really easy to do. So this is something that's pretty cool. Again, you get all the features that you would typically expect from SAN: snapshots, access management, you can encrypt. As I mentioned, the newer instances that Amazon are releasing, the trend appears to be no local storage for new instances, but massively increased throughput to EBS. I would still say, even with that in consideration, because as DBAs we're highly concerned with storage performance, I would still consider striping across RAID 0 striping across multiple volumes just in Windows. The overhead for doing that CPU-wise is pretty low, and you're addressing a SAN that has 5 nines of availability, so it's not like a super risk. It's not like a typical RAID 0 scenario, but it will potentially increase your throughput considerably. Then we have this concept of general purpose versus provisioned IOPS. So provisioned IOPS are this idea that basically I need a certain set amount of IOPS guaranteed, and I'm willing to pay for the guarantee that the IOPS requirements will always be met. This is not very common for SQL Server. General purpose is kind of a bit more like the over provision type scenario. You're accumulating credit in the bank, and you get a certain amount of base IOPS based on the size of your volume, but you can burst up to a certain level occasionally and then expend your credits. And generally, I've found that if you make your general purpose volume big enough to meet your base IOPS requirements, even if it's much larger than the actual size that you need to store your database, that actually this can work out cheaper than setting your database volume size to the size that you need and then getting provisioned IOPS to guarantee the IOPS. So particularly in workloads where if your biggest burst is when you do index maintenance or when you do backups, I would definitely look at general purpose. But if you have the kind of workload that absolutely needs 20,000 IOPS per second all day long, well then you really have to look at provisioned IOPS. Okay, so migrating to AWS, right? This is very similar to migrating between data centers, except for with this slight exception, if your migration strategy involves deracking all the servers, throwing them in the back of your van and driving to the new data center, That's not going to work with AWS. But outside of those options, it's pretty much the same thing. And the things you need to be concerned about, you need to understand your data and you need to understand your workload. You want to think about what are your current bottlenecks and let those inform the decisions around, because probably the biggest decision you will have to make if you need to run SQL Server in AWS, once you've moved past the RDS versus EC2 option, and I think for most workloads that DBAs manage, you're probably going to want to go with EC2, just for the flexibility. Outside of that, then you need to pick an instance type. And the factors that are going to inform that are cost, performance, and flexibility that you have to upgrade. And again, like with any kind of migration, what are the transactions per second that you need? You know, what are your IOPS? What kind of storage latency can you tolerate? What are your throughput expectations? So basically, as I say, getting there is basically moving to a new colo. It's the same challenge. So basically, your boss says, we're moving to a new colo. And key takeaway always, and I mean, this goes for basically any project that anybody ever does, is don't ever assume that things will just work, right? You really need to test and make sure that you invest the time and effort to be able to guarantee that this will work, because it will always come back to you if it does not. Okay, I'll talk a little bit about the concept of dedicated hosts and dedicated instances. So dedicated instances are basically AWS or Amazon guarantees that you will not share workload with a different customer. So this will be for, you know, if your InfoSec team has a concern that there might be an exploit, Amazon uses the Zen hypervisor. So if your InfoSec team had this kind of like concern that an exploit there could allow some other customer who shared the same hardware as you to, you know, somehow intercept your workload, this will be a way to mollify that, right? You can say that we've just got a guarantee that, you know, the only instances that will ever run on this hardware will belong to my company. Amazon says these are priced differently, by which they mean they are more expensive. Dedicated hosts then is kind of more of a different concept again. So it's you are licensing the entire physical hardware. This is kind of equivalent to the license by host model that you get with VMware, and I'm sure that Hyper-V has something similar. But this is the, you know, Amazon will tell you what the hardware specs are, you license the whole, you pay for the whole thing, and you take care of licensing top to bottom. Whatever you want to install on there is fine. And this is probably the only way for if you want to bring, particularly now that modern versions of SQL Server require software assurance in order to migrate licenses that are perpetual licenses without software assurance. This might be the only way you could do it. So it's useful from a licensing perspective. Definitely it's very useful if you want to bring your own license for Windows OS, and Amazon will expose all of the details about the hardware to you so that you can accurately report back to auditors and make sure everything is good there. And very, very new, and recently went GA. Obviously there's been some overshadowing of announcements coming from Vegas recently, but there's recently AWS announced that they will basically have partnership with VMware, and you have to think that AWS doesn't have a big on-premise, it has really no product to offer if you want to run their stack on-premise. So they've partnered up with VMware as a kind of hybrid solution, because VMware does not have really a good solution for if you want to run their stack in the public cloud. So they've partnered together, and everything about this solution of VMware on AWS, now it's not any kind of weird like EXI running on Zen kind of nonsense. Basically, VMware's ESXi product runs on the bare metal on their i3 class hardware, uses virtual SAN in the background across all these up to 16 terabytes of NVMe drives. I think you have a minimum of 3 hosts that you can join in a cluster. And from that point forward, you're dealing with support for VMware. Everything is done through VMware, which has really good support. If you happen to be a VMware customer, you're probably aware of this. So basically, they're just using AWS just for their data center expertise. And this can be quite nice because it gives you total control. If you have orchestration or automation tools built around VMware, well, then these will continue to work. You can actually, I mean, I probably can't find a real justifiable use case for doing this beyond that. It sounds really cool. You could actually technically vMotion something from your a server from your own on-premise location right into the AWS public cloud using VMware on AWS. So that is pretty cool, and it's definitely an option worth considering. Pricing wise, you definitely need to investigate, but because my initial feedback, I haven't delved in super deep or anything, but my initial feedback from what I saw is that it does seem kind of expensive, but something at least worth looking at. Okay, so HA and AWS. Well, if you're using RDS, as I mentioned, Amazon's managed relational database service, it's based on mirroring. We all know that mirroring is deprecated, but it's still based on mirroring and it's still supported. Even right up into 2016 and 2017. And the way it works is that, you know, upon a failover, the endpoint that AWS gives you gets a new IP that corresponds to the failed over to instance. So it's important that your clients have a very low DNS cache in order for this to make it work. There's no point in failing over and having your database available, but it taking 4 hours for the DNS cache on your clients to expire in order to realize that basically there's, you know, a new instance available. That is a completely hypothetical situation. So if you're running in the EC2 or basically VM land, of course, there's no failover cluster instances or SAN-based type replication scenarios. There are some software SAN type products. I've never really looked into them too much. I've had some people say they've had some success with them. It's not something I've looked at much, and personally, I would tend to stray away from anything like that. What EC2 is very good for, works really well, is availability groups. You will be doing multi-subnet clustering. Don't be scared. It's, you know, super easy, and if you happen to be on Windows Server 2016, which you probably should be, it's like a dream. It just works perfectly. Mirroring still supported, log shipping still supported. If you happen to be on standard edition and you don't want to go into the basic availability groups world, yeah, log shipping will still work for you. Okay. Hey, Tom, we got any questions coming in so far? I think
Nope.
I'm just
Nope,
okay.
pretty good.
I think I'm just about on track. I'd say some of these ones, like, you know, disaster recovery and high availability, I mean, these are in-depth topics by themselves, but I'm just kind of briefly covering them and kind of how they touch on AWS. And if people have more like kind of in-depth questions, all my details are available on these slides. Please feel free to, you know, send me an email, hit me up on Twitter. Yeah, I'm, you know, I make myself available. I'm happy to talk about SQL Server all day long. My wife keeps wondering, you know, do you have any hobbies? I say, well, it's kind of what I also do for a living. So disaster recovery. So if you're in the RDS world, as I say, the managed database service, so you can do things like you can export your backups to S3. That's Amazon's object store, and you can replicate that out then to basically any other region. It's globally available. The way RDS does backups, it's snapshots, like SAN snapshots. They are supported SQL Server. I'm talking about this a little bit in my talk about managing large databases. But the way AWS does it is a fully supported way to do SAN-based snapshots. You can also export your snapshots to a different region. That's actually what we do. It's just very simple. And when you want to restore a snapshot to a particular point in time, and as I mentioned, don't forget you've got a 5-minute granularity on this. How long it will take will really depend on your transaction log activity. So restore the snapshot in the recovery mode and then start replaying the logs into it to the point that you've requested. If you're an EC2, well then, it's up to you. Basically, it's all on you. Typically what I like to do, and there are products that will present an S3, again, Amazon's object store, equivalent of Azure Blob Store, that they will present this as a physical drive. I don't recommend doing that. I back up to a local drive that's fast, that's an EBS volume, that's highly available. It's got your 5 nines of availability. I back up to that, and then I have a script that runs and exports what I need to retain, one 1 month copy, 1 year copy, so forth. I can set my retention policy and keep them in S3. And you can actually, in your S3 bucket, you can actually set the retention policy there. So after a year, stuff goes into Glacier, which is super cheap to store, but takes a long time to restore from and costs money to restore from. But if you need a database backup from a year ago, there's probably something big enough that you really don't care about paying those costs. You could potentially use EBS as a concept of snapshots, but the way you would need to take things is you would need to briefly shut down SQL Server, initiate the snapshot, and once the snapshot is initiated, you could start back up SQL Server, but people usually aren't super keen about downtime to take a backup. But again, it could work in some circumstances. And of course, hey, for DR, you could just have an availability group in a different region and just asynchronously back up to that, to a different replica in a different region. We do that, again, works perfectly fine. You just want to make sure that either you have the WAN connectivity supported or the internet connectivity supported. But yeah, from a technical standpoint, this works absolutely fine. Okay. Getting close to end of time here. So monitoring SQL Server in AWS, right? So you can use your own. That's what we do. We use Nagios and we monitor the instances that we have running in AWS pretty much the same as we monitor everything else in our environment. If you are using RDS, you will come into hit some limitations around that, because you're locked out of certain things. You are not the sysadmin, so there are some limitations. But CloudWatch, which is Amazon's own monitoring product, it has a lot more useful stuff in RDS. It gives you most of the metrics that you need. If you're running EC2 and you want to use CloudWatch to monitor your SQL Server instance, you're going to have to build a lot of your own custom metrics, and that's why we ended up just using our own Nagios solution that we already use. You can pay extra and use what they call detailed monitoring, which gives you basically down to the minute granularity. For what we currently run in RDS, we haven't found this necessary, but it's definitely an option that could be useful for some people. You also have a concept of CloudTrail, which logs all of the API calls into S3, and this is, again, it puts it in a immutable S3 bucket that data can't be changed, and this can be useful for like compliance auditing type scenarios. And in some ways, doing audits and meeting your audit requirements in AWS is somewhat easier sometimes than on-premise. Okay, I promised a really brief slide on licensing SQL in AWS. So if you thought it was complex in the virtual world, this adds an additional layer of complexity. It is absolutely fully possible to bring your own license regardless of whether you use RDS or EC2. Actually recently talked to Microsoft, and they said they are not aware of anybody doing anything other than bringing their own license for Enterprise Edition in the public cloud across Azure and AWS. So it used to be this kind of really weird form that you had to fill out and fax to AWS, which is kind of mind-blowing given, you know, that it's not 1983. So this has changed. Now you can do it all online, but the point remains the same. When you essentially tick a box to say, I will take care of the licensing, so they expect you to fill out a form and inform Microsoft within 10 days of you spinning up an instance to let them know that you are bringing your own license to the cloud. If you want to do what they call license mobility, you need software assurance for SQL Server. And that's been a trend for a lot of different things, and a lot more things have been tied to software assurance, and this is to make sure that people stay current with their software assurance. This was more of a deal when you had such big gaps. 2000 to 2005, that was a huge gap. Typical software assurance arrangements are 3 years. How much benefit people got from having 3 years there is kind of low. So this is something that's becoming increasingly prominent. So what they're saying is you can take your licenses, your SQL Server licenses, and move them to the cloud or license mobility, but you gotta inform Microsoft and you gotta have software assurance. If you're using dedicated instances, that can be a workaround for software assurance. Host licensing only available with dedicated hosts. I remember I covered the difference between instances and hosts. And the license included, and so this is like pay by the hour. They're both available for RDS and EC2. But if you want to use EC2, which as I mentioned is similar to VMs, if you want to use EC2, then you have to use AWS's own image. You can't bring your own media for this. And if you've ever kind of installed SQL Server and wondered about the checkbox that says install everything with defaults and stop asking me questions, that's the AWS AMI. So it's not great. I had to write whole scripts to kind of like unfunk a lot of the weirdness that occurs when you do that. But if you want to pay by the hour for SQL Server licensing, that's how you do it. And RDS has support 2008 R2 all the way up to 2016. 2017 is not available yet, to the best of my knowledge, but I'm sure that's going to change sometime soon. Running close on time, so a couple of brief learnings. It confused our sysadmin team because if you read the documentation, when you're setting up a multi-subnet cluster, everything that they talk about, what they call private elastic IPs, which are basically IP addresses that you are assigning within your own internal subnet. They always talk about per adapter, but it's fully possible to assign multiple to an adapter. And this is necessary because if you're setting up multi-subnet clustering, you're going to need multiple IP addresses, not all of which are going to be tied to a particular adapter. If you're using EC2 instances, I would heavily suggest that you build your own private AMIs exactly like you would do if you're using VMware or Hyper-V. Build them how you want, configure them how you want, maintain them how you want, and spin up instances from that. If you're using Windows authentication on RDS, you might see some older blog posts where they say, hey, you know, SQL Auth is the only thing available on RDS. That is no longer true. but you do need to use AWS's own Active Directory service. You can't just like kind of set up your own domain, connect to that. It's that Active Directory service can be part of your domain, but it does has to be their service. Put SQL into its own VPC and security group. Be prepared. Remember again, like for your sysadmins, it's going to be kind of freaky, and there's going to be Active Directory, but they don't have full control. There's going to be parts of it that they're locked out of, and there's going to be some quirkiness there. And I typically find that new features are released frequently, but usually right after. They'll say, hey, who needs more memory? Or hey, who needs more of this? But yeah, usually they're released right after you need them. And all right, so, and this is just a quick, we're running out of time here, so this is just a quick example of how you set up your availability group listener to use multiple IP addresses, and how you kind of set the OR logic, so basically you can run on either subnet. All right, so to summarize, totally possible to run SQL Server in AWS. Just plan carefully, follow your guidelines, benchmark and baseline your workload. Treat this like you would any migration project, but remember that you do not own this infrastructure. But at the same time, leverage the benefits of the toolings. You get to use multiple data centers, multiple regions, and you can just have a lot of fun. You can do a lot of cool stuff. We have automatic failover between 2 data centers outside of AWS, so that's actually a really hard thing to achieve. All right, that's me. These are my contact details. If anybody needs to get a hold of me, this is how you do it. And please, I'm happy to talk SQL all day, so please feel free to hit me up any questions whatsoever. Tom, any questions?
Nope, there's no questions in the queue currently, Brian. I appreciate your presentation today. For everyone, it will be up on YouTube within the next day or so. And I'll get Brian's slides also and put them up there on the Virtualization SQLpass.org website. So thanks again, and we'll talk to you next month.
All right. Well, thank you very much, Tom. And actually, because I'm presenting this from the office, I actually have people trying to get into this room. So I will drop out, but
all right, we'll talk to you later.
Talk to you later. But yeah, my email address is there. Please feel free to hit me up any questions whatsoever. Thank you.
Thank you. Bye-bye.